Now we are done with the limits. We will start a new lesson called continuity. What continuity means? The most important thing about continuity is these three conditions. So, if a function is continuous at a number c, if the following conditions are satisfied. What are these conditions? First of all, f of c is defined. Limit of f of x as x approaches the c exists. And number one answer and number two, which is the limit of f of x as x approaches c, and the f of c are equal. Study the continuity of f at x is equal to 2. And as you can see, that's the graph which is given. Let us start with a condition. First, I need to find whether it's defined. With an open dot, do you think it's defined or not defined? Excellent. Study the continuity of the function at f at the x is equal to 2. Let us study this graph. The first condition said f of c is defined. Do you think that f of c, even if there's an open dot, it's defined or undefined? Of course, excellent. So undefined. So because of the first condition failed, directly, without thinking about it, ما في داعي نرجع to think about this one. Discontinuity at x is equal to 2. Perfect. What about this one? Let us start. If I'm asking for f of 2, you will say that the answer with the solid dot, which is a 3. Excellent. If I'm asking about the limit, you will study the limit based on the graph. Approaches from the right, which will be as simple as this, a 1. And approaches from the left, which is also will be a 1. So limit of f of x as x approaches the 2, it's a 1. So do you think the 3 and the 1 are equal? F of 2, is it equal to the limit? Of course not, they are not equal. So the third condition failed directly. Discontinuity at x is equal to 2. You must follow the steps. Do you think this is continuous or not continuous? Let us think about it. If I want to find f of 2, what happens in this case? Where's the solid dot? You will tell me that f of 2, excellent. It's a 1, perfect. When I'm asking about limits, you will say limit approaches from the right, it's a 1. Limit approaches from the left, it's 3. Perfect. So right, it's a 1. Look at the graph and decide. Left, it's a 3. So 1 and 3 are not equal. So limit of f of x as x approaches the 2 does not exist. So directly, discontinuity at x is equal to 2. But what about part D? Look at the graph. Before studying the conditions, do you think that this is continuous? Good, excellent. Let us prove it now. Now, first of all, if I said f of 2, you will tell me that the answer is 1. Perfect. If I want to study limits from left and from right, you will tell me that the answer is 1. Also, perfect. Next step, limit as f of x as x approaches the 2, it's 1. So these two are equal. The first and the second condition are equal to each other. So the second and the f of 2 is equal to the limit of f of x as x approaches the 2. So it's continuous at x is equal to 2. So now did you understand what do we mean by continuous? We will follow the conditions. But continuous means there is no cut in the graph. The graph is continue. There is no cut, there is no open dot. Classification of discontinuity. We have the first name for that, something called removable. What do we mean by removable discontinuity? As simple as that, this is an example about removable. When the first condition failed, f of 2 is undefined and it looks like that, empty dot on this, so this one called removable. And this one also the same thing. If the first one, you have an answer for it and the limit different answer, and when you may want to see whether they are equal or not, you found out that they are not equal, so this one also called removable. Now what infinite? Infinite means infinity. Yes, you are right. So vertical asymptote line, and as you can see, looks like that. F of 2 is undefined, and the limits is going to infinity, so we will call it as simple as that, infinite. discontinuity. The same thing over here. F of 2 is undefined, and as you can see, limits is going to infinity, so for that reason we will call it. Let us study the jump. Now, f of 2, it's what? It's a negative 1. Perfect. Now what about a limit? Let me study. Limit from right, it's a negative 1. Then what about from left? It's a 1. Is it equal? Of course not. Does not exist. So what did you understand over here? What's the conclusion about the jump? Jump, basically, you will look at, or the problem always at, the second condition. So the first condition, it will be defined, and we have an answer for that. But the problem always with the second one. The limit does not exist. For that reason, we will call it jump.